So what I mean by a to the x, I mean some constant to the x. So I'm going to take the derivative with respect to x of some constant to the x. Again, that could be, for example, the derivative with respect to x of 2 to the x or something like that. Agreed? All right. How do I do that?
Bring down the x.
You don't bring down the x because the x was at the bottom, and that was a rule that worked when x is at the bottom, but does not work when you're talking about a constant at the bottom. It is not just a to the x. E to the x is because it's the one that actually does this. None of the others do that, but we're going to use that same property to figure this one out. We're going to say, well, wait a second. And again, this requires nodes and logs. My bad. But what? But? Okay, so what we're going to do is we're going to go... what was I going to do? I was going to do something really fancy here. Derivative with respect to x. I'm going to have to cheat. Hold on. Let me think. It's ln e.
It's ln
a to the x. Okay. Ln, if I go...
ln of a times a to the x.
Yeah, but I got to put an e in there because otherwise I'm changing what it is. So it'll be ln e to the a to the x. I think that's what I want to do
ax
here.
or to the a to the x?
Oh, a to the x. I'm going to fix that in a moment anyways. A to the x.
Wow, that's kind of...
So, see, to what power do you need to raise e to make e a to the x to be a to the x, correct? I've not done anything goofy or weird or new or even different. So far, so good?
Yeah.
Now I'm trying to figure out what I'm supposed to do from here. To the raises of power, I can throw that out in front. Now I'm wasting time. Why am I wasting time? What am I doing wrong here? Something. I wonder if I'm supposed to go the other way. What if I'm supposed to go the other way? Hold on. Let me see if I can try it this way. See if I get a better thing. E ln a to the x. Yeah, that's going to do a good job for me. There we go. That's what I want to do. Okay. Now, all I did is I said these are opposite functions, right? So I'm raising something to e and then lowering it back down again. That's what the ln does. Have you got me so far? Okay, I only have you paying attention, so that's good. All right. So moving forward, how do I take the derivative of this? We know how to take the derivative of this. How do we take the derivative of this? And e to the x, e to the x. Now, before I do that, this is kind of spooking me out. So can I move this over here? Because it's an ln, I'm allowed to do that. So I'm going to rewrite this as derivative with respect to x of e, x to the ln of a. And then I'm taking the derivative with respect to the wrong thing. So I'm going to make u equal to x ln of a, correct? And then I go derivative with respect to u of e to the u times the derivative with respect to x of x ln of a. And ln of a is just a number, right? Like 5 or 6 or 12. Probably not one of those numbers, but like that. Got it? So then I take this. This is just going to be e to the x ln a, right? That hasn't changed. And then this is going to be something weird. This is going to be ln of a, right? Because I lost the x. Because this is a number, we lose the x. Are we with me so far?
Right, so why are you taking the derivative with respect to the wrong thing? Aren't you just doing it with respect to x?
We only know how to take the derivative of e to the x.
Right.
So I have to make this into a u in order to take the derivative.
Oh, I see.
Right? Remember that?
I thought you meant we had like a y or
No,
something.
not that kind of wrong thing. All right, so now I've got this thing set up. Now notice, remember this is just a to the x, right? Put the x back in, bring it down. This is just e to the, sorry, this is not e to the anything. It's a to the, whoop. This is just a to the x ln of a. Right? This is e to the x, which was this thing here, which was this thing here, which is the derivative we started with, a to the x. Can we go backwards through those? All right, let's go backwards through those. E to the x ln of a. I put the x back in. This becomes e to the ln a to the x. And then e to the ln just goes away and gives me a to the x. Back where I started.
Oh, I see. Okay.
So the derivative with respect to x of a to the x is a to the x with an ln a that just suddenly appears. Magically.
So the derivative of 4 to the x is 4 to the...
So the derivative with respect to x of 2 to the x, which is the one I started with, I'll do this as my example, okay, would be equal to 2 to the x ln of 2. Done. Now, do I expect you to do this every single time? No, I expect you to memorize this one. You have to. Okay? Now, if that's the derivative, what's the integral? Integral would be going opposite, right? So I can say the following. I know the derivative, with respect to x, of a to the x equals a to the x ln of a, right? So if I was going to integrate, the integral of ax ln of a is equal, dx is equal to ax. We agree on that?
Yeah.
So if I move this over, because this is just a number, right? I move it out in front. Agree on that? And I divide it across. I get the integral of a to the x dx equal to 1 over ln of a to the x. And that's how I get my integral.
Wait, what did you? That's an integral.
What, where?
Can you just, sorry.
Go through it? Okay. I know this is true, right? Because we just proved that. To find the integral, I would note that the integral of this would have to give me that, correct? Because we're going backwards?
Yeah.
Antiderivative. So far? So then I just set it equal. It said the integral of this is equal to this. Great. And then I noted this is just a number, so I pulled it out in front. And because I want to know what the integral of this is, I divided it across the ln of a. And I might add a plus c here, just so you guys don't forget. Just so you don't forget.
Can you
Okay.
write it as a to the x over ln of a, or is that not?
Yes, that's fine. Totally fine. Is that the way I wrote it? Probably did. I'm lazy. Lazy cuz I probably did right. No, I wrote one over. Ha ha ha. No, I didn't. Where is it? I can't even find it. I didn't even do it. Where the heck is it?
Maybe come back then.
What? Wow, I did something that's not even on the front of your page, it's on the back of your page. That's excellent. Good job on me. All right, try problems. 37, 39, and 41, and then I will give you another burst of fun. Our last burst of fun, if it makes you happier. Well, those are on the top. Well, go ahead and write the integrals on top. I did not do the integral for you guys. Write that on top. Write that on top.
Which the one under that has the one? Is that different?
There's some log ones. I haven't done those yet.
Oh.
Those are coming. I thought those were on the front of the page, but apparently they are. So, my bad. Where is my stopping? Moving on. So 39 would be g of t equals t squared 2 to the t. So look at this go. Ah, two things multiplied together. I have a product rule. Hooray! I love this problem, by the way. It says AP Central because it messes with your head. I don't know why, but it does. So I did derivative of the first thing, which is 2 to the t, 2t, right? Plus derivative of the second thing, which is 2t. Then this is now we just discovered what? 2t ln of 2. And I'm done. So 41. H of theta equals 2 negative theta cosine pi theta. Okay. Same thing on a product rule. So do the first thing. That's a little tricky because it's got a negative in front of it. So taking the derivative, I'm going to have to use the chain rule on that, correct?
Yes.
Right? So it's definitely asking for this one. You want to use substitution chain rule or do it the interceptor? It looks like use substitution wins. Whoops. I need an eraser, not a scratch it out thing. Okay, so then I would go u equals negative theta. Great. So then I would go derivative with respect to u of 2 to the u times derivative with respect to theta of negative theta. All that times the unchanged cosine pi theta plus 2 to the negative theta. And then I got to do the derivative of this, which would be negative sine pi theta times pi, right? Because that's the inner outer. So that's good? Okay, so this just becomes 2 to the negative theta ln of 2, agreed? Times derivative of negative theta, which is negative 1, times cosine of pi theta, plus 2 to the negative theta Oh man, I'll put a pi in front. I'll change this to a minus sign. Minus 2 pi sine pi theta. I should move the minus in front over here and call it a day. Agreed? Is that okay, Emily?
Yeah.
Product roll, product chain. Isn't that fun? Product chain. Actually, product chain. Chain. Two-link chain. All right, so I've got an integral of x, 5x to the negative x squared dx. Agreed? All right, take a look at this. Go. Oh, crap, it's an integral. I'm not using a product rule. I've now got to figure out what to do. I've got a couple options. I can't just integrate that because I got the x and the other thing. So I'm going to go u set u equal to the ugly part. U is ugly. So then I go derivative. Du equals negative 2x dx. Need to make a negative 2x inside. I've got the x. Need a negative 2, so I'm going to go ahead and put a negative 2 here, and then I'm going to get a negative 1/2 out in front to make that happen. Agreed?
Why is it negative?
Are we just ignoring that?
What's the derivative of negative x squared?
No, but like, is it negative 1/2 and 2? Isn't it? Like, why is it 1/2? Why is it just 1/2?
Because I need to put in a negative 2. If I put in a 1/2, I put in a negative 1, and I change my answer. I've got to cancel that out, right?
Yeah.
Oh, you're right. I forgot about the 5. Let's throw the 5 out because we just did that. So I would have 5 times negative 1/2 times the integral of x. Is it x to the negative?
No.
What did I do? Oh, it's 5. I got an x in there. It's random. I can't throw the 5 out. What the heck am I doing? I'm not even writing down the problem right. Hold on. Negative x. That's 5 like this, right? So now I'm not throwing the 5 out at all because it's critically important to the problem. All right. Lost my train of thought over here too. That's awesome. All right. See if I can get this back before I go crazy. So I have 5 to the negative x squared, negative 2x dx. Agreed? So that's du. This is u. So I go 5 to the u, du, integral of negative 1/2. And what is the integral of 5u?
5u plus.
5u. What?
1 over.
It's
Times 1 over ln 5.
oh.
And I've still got the negative 1/2 out in front. Plus c. And I might as well go one more level. So I go negative 5 negative x squared over 2 ln of 5 plus c. Ain't that fun?
That is quite doable.
Yeah, no, 65 is very doable. Just an ugly substitution.
I think
I will do it in just a moment. Everybody's got to try it, though. Otherwise, I will be doing your work for you.